Hello everyone, this is a video created by Risk Consult from Austria, and we would like to talk to you today about an integrated cost and schedule analysis. We have prepared for you a RIAAT walkthrough, and we have also prepared a sample project of a base tunnel that we would like to utilize to give you a hands-on demonstration of each of the steps needed to build a proper RIAAT model. Before we go into the software, I would like to talk to you about some fundamentals. On the left side, we see a cost component structure visualized in a waterfall diagram. It consists of three cost components, BRE, base cost, risk, and escalation. Base cost is the cost that materializes if everything goes as planned, without contingencies. The contingencies move up to the risk cost, which typically consists of a markup on base cost for unknown risks and identified risks, which can be quantified in terms of probability of occurrence and cost and time impact. And then on top of that, we add escalation, which accounts for the future market development in terms of price increase and also in terms of when do you spend your money. Because if you build your project next year, your escalation cost will be much smaller than when you build it in 15 years. The three of them together are called BRE, which is the total project cost. Now let's look into the process. It starts on the top left here with the base cost estimate that we either do ourselves or we get from the design engineer. We want to take the base cost estimate and add ranges to it, as indicated by this small picture here, to account for variations in quantities and unit prices. And after we have done that, we integrate the base cost into the work breakdown structure, the WBS. The second step is the risk assessment, which you see on the top right here. It consists of two parts. The first one is finding a markup in terms of percentage of base cost for unknown risks. And the second one is identifying, describing, and then quantifying specific risk scenarios in terms of probability of occurrence and cost impact and time impact. The cost impact of identified risks together with the unknown goes directly into the WBS. The time impact is assigned to our schedule. If you compare these two, this is a deterministic schedule, and this here is our risk schedule. So the risks are assigned to tasks which will lead to uncertain completion dates. We have no fixed date anymore, but also the completion date or all the milestones in the project are described with distribution functions, which is indicated by this picture. So we get as a result uncertain completion dates, we get possibly multiple critical paths, and we get delay from risks which are then associated with time-dependent cost and linked back to the WBS. This is a key step, and this is why it's called an integrated cost and schedule analysis, because we want to cover the cost of schedule delays in our cost model. For large infrastructure projects, cost overruns are very often a consequence of schedule overruns, so this step down here is a key step for our integrated cost and schedule analysis. Now, after we have done that, we get cost results in terms of the cost component structure that we have defined on the left: base cost, risk, escalation cost, and the sum of the three, BRE, total project cost. We can visualize the distribution functions of each of the cost components in one single graph. On this axis here, we have cost in terms of millions of US dollars. And on this axis, we have cumulative frequency, which can also be interpreted as a probability of not exceeding a certain cost level. Now let's look at the distribution functions we have in this graph. The first one here is a vertical line. There is no range included, it's just one single number, 747.7 million US dollars. This is our deterministic base cost. If we add ranges to it to account for variations in quantities and unit prices, we get the blue distribution function. If we add risk to that, we get the red distribution function. And if we add escalation to that, we get the green distribution function, which is our total project cost, which in this case here is between 1.1 and 1.3 billion US dollars. Now, what do we do with that information? Let's assume we want to have a certainty of 80% of not exceeding our budget. Then we go to 80% here, and we see this is the relevant number for us. If we want to have an 80% chance of not exceeding our budget, this is the number we have to put in our budget, 1.266 billion US dollars.